Hi, welcome to this lecture. So in this lecture, we'll talk about how you can calculate some band information, or you can do, for example, NDVI calculation using a variety of approach. Okay, so the first thing is you need to import the Earth Engine um, Python API, execute this first batch of scripts to install, authenticate, and initialize Earth Engine. You've done this in the previous lecture, I hope. If you have not done so, please do that. The next thing is just call the map canvas folium library to provide some sort of background display. Here you can choose the hybrid or the satellite background if you want. So the main part of our lecture is here. So what we'll do is I'll show you two approaches on how to calculate NDVI. NDVI is a normalized difference vegetation index, which is a spectral index or a transformation, a band transformation, mostly calculated using a normalized near infrared and the red band of the spectrum. For each sensor, you can have different band combinations, right? So here I'll import the two Landsat years. The first one is Landsat data for 1999 here. This is Landsat 7, as you can see, LE7, and which is a 5-year average or an epoch data. And the second one is Landsat 2008. Here again, Landsat 7 data, 5-year top of atmospheric reflectance. So the first formula is a bit hard, calculating NDVI the hard way. So it's NDVI is calculated by subtracting band 3 from band 4 and also dividing that by the summation of band 3 and band 4. So technically what we're doing here is just exactly that. So I'll use Landsat 1999 here and subtract band 3 from band 4 and divide that, and also the summation of band 4 and band 3. So this is the long way of calculating NDVI. The other approach is, for example, here I'll use the 2008 Landsat data here. I'll call it NDVI 2008. So I'll call this Landsat 2008 data over here. And what instead of using this subtraction and addition, I'll call an Earth Engine built-in algorithm, which is called normalized difference. Dot normalized difference, which is here. It will automatically calculate NDVI, but I need to provide the two band names, band 4 and band 3, which are used to calculate NDVI in this case. So I've shown you two approaches of calculating the hardest way, or just the long way of calculating NDVI, and also a more efficient way of calculating NDVI using the Earth Engine built-in function. Okay, normalized difference here. And the next thing we need to do is provide some sort of visualization parameter. I'll call it NDVI parameters, and define the different color that I will use when I display these maps. Okay, so let's first display NDVI 1999 here. The first NDVI we calculated the long way approach, right? And the second display is NDVI 2008, which is calculated using the Earth Engine built-in function called normalized difference. Here I'll call it NDVI 2008, and the first one is NDVI 1999. Both of them will be displayed once I execute the next batch of the script. So let me go ahead and execute this batch of script lines of code. And the last thing is I'll execute map to display my NDVI calculations using Landsat data. So this is let me just toggle this. So NDVI 1999 here, as you can see, for example here in Africa, and at NDVI 2008. So these are epoch level data that we calculated using Earth Engine Python API.